Hello and welcome to this video on motor control schematic basics. Basically, what we're going to try and focus on in this video is going to be an overview of ladder diagram basics, normally open, normally closed, or NONC push buttons. I'm going to mention contacts as well. Rung labeling, wire labeling, coil and contact cross-referencing will also be covered in this video. Alright, so first we're going to start off with a 2-wire control circuit, and in general the rules and regulations surrounding control circuits require that it always be isolated and protected separate from the actual power in the building, or the power circuit rather. So the control transformer's primary sides, in our case, will be hooked up to H1 and H2, line 1 and line 2 having 208 volts as the building is fed with a Y system. On the secondary side of our transformer, control transformer that is, you'll see X1, X2 is formed as the transformer secondary. That is stepped down to 120 volts AC and protected by a fuse or a circuit breaker typically. Moving down from there, the reason why this is called 2-wire control is because from the power rail to the switch and then to the actual control device or the coil, or also known as the load, there's 2 wires that turn that component on. See here, 1 and 2. Now a couple other numbers to recognize are excuse me, the numbers down the left side here. So each rung of logic that goes from X1 all the way across to X2, okay, is considered a new rung. Now, if we were to have a contact underneath this, as you'll see in the next drawing, that would also be considered a new rung. Alright, much of this holds true with hand-drawn or blueprint schematics, typically ladder diagrams, elementary diagrams. But when working with PLCs, because of the way PLCs scan, some of those rules and regulations change as far as how things get labeled. Alright, next you see the coil, and then after that is a normally closed overload contact. Okay, a normally closed overload contact is typically the only thing you'll ever put after a load. Alright, so this right here, the coil would energize, the contact would close, lamp 1 would come on. Jumping over to 3-wire control. So 3-wire control, we see our normally closed stop button, or normally open start button, 2 normally open contacts, and then again that overload protection after the coil. So keep in mind, this is not the physical layout of these components, but it is how they would be wired. So we have rung 1, rung 2, rung 3. The normally closed stop button means that we should measure 120 volts right now without the circuit activated but energized from wire number 2 to wire number 5. As soon as we press start, you'll be able to measure voltage from wire number 3 to wire number 5, or record voltage. That is the amount of voltage that will be dropped across the coil. At this point you could also see 120 volts across 3 and 4. Now with the motor starter coil energized, all of its contacts will change state once the coil is energized. So you'll see this normally open go closed as the holding contact, and you'll see this normally open go closed as well, turning on the lamp. Current will continue to flow through the coil so long as the stop button is not pressed. Depressing the stop button will break the flow of the path of current to flow, and de-energize the coil. Alright, these are both momentary push buttons, so they are referred to in their on-operated state. Thanks for watching.